ratio. Every lot of thromboplastin is also required to have a population mean derived from the normal population. For this, an estimation of MNPT or mean normal prothrombin time is required. A laboratory can estimate the MNPT from a minimum of 20 healthy individuals with a relatively equal mix of both sexes over a range of age groups. People on anticoagulants, pregnant women, people with known bleeding tendencies should be avoided. Estimation of a geometric mean is to be preferred to the arithmetic mean. MNPT samples must be fresh. The mean of a laboratory normal control is not an acceptable substitute for the MNPT since control samples may differ excessively from each other, particularly in the case of less responsive reagents. The MNPT should be determined with each new lot of PT reagents.
Calculation. It is advisable to have a software like Excel to make the calculations easier. Say, 20 samples are run in duplicate. The mean of both runs for each sample is calculated. Calculate the percent difference between the two readings. The percent difference should be less than 10. Exclude all the outliers that have a percent difference more than 10. In our example, one set of values shows 12.5% difference. Exclude this one. Then, the geometric mean of all the 19 accepted mean values can be calculated by inserting a simple formula on your Excel sheet. In our example, it comes out to be 11.25 seconds. Now, calculate the standard deviation on the 19 sets of means by inserting a simple formula on your Excel. Standard deviation in our example is 1.51. Geometric mean plus 2SD and geometric mean minus 2SD will give you the upper and the lower limits or the range between which the values should lie. Hence, the upper limit is 14.27 seconds and the lower limit is 8.23 seconds. Now, look through all the mean values to see if any exceed the specified limits. Exclude all these outliers. That is, any value that does not lie within this range. In our example, these values are 16.45 and 8.15. 16.45 is greater than 14.27 and 8.15 is lesser than 8.23. Calculate the new geometric mean with the inliers. It comes out to be 11.22 and this is mean normal prothrombin time for this lot of thromboplastin. As is evident, the MNPT has been changed from 11.25 as in the previous calculation to 11.22 now. Since the standard deviation has also changed, the ranges also change accordingly. This final range, 12.32 to 10.12, will serve as the biological reference range for this lot of thromboplastin. The biological reference ranges stated in the literature are generally between 10 to 12 seconds for human thromboplastin and 11 to 16 seconds for rabbit thromboplastin. However, this cannot be used for patient reporting. Every lab is required to calculate the MNPT and the biological reference interval or range as per this above method. Once the MNPT is known, INR can be calculated by this formula. INR is equal to patient's value by MNPT value raised